So now we get to the exciting stuff. Now we're going to connect SQLite with Python, so our back-end programming language will be able to communicate with our SQLite database so that we're going to be able to store records, be able to update records, be able to get record values back. And so now we have some place to actually store the data that our users are giving to us. So let's look at a basic overview of how Python is going to be interacting with your SQLite database. So whenever you're using Python, again, you are going to have to import a module to do almost anything. And so here we're going to import SQLite 3. So SQLite 3 should be one of the default core packages that are installed when you install Python in your system, so you shouldn't have to do anything else there. Then we're going to create a connection. They're going to create a connection. So we're going to do con equals SQLite3 dot connect to the database, right? And so again, this is going to be just like when we were at the command line trying to interact with the database. It will either connect to the database that exists or it will create one. So this is very important for you with understanding the working directory, right? So if you have this database file, but it's somewhere other than what Python currently thinks the working directory is, then Python is simply going to create this new database, and then everything that goes past this will be trying to interact with that database, which can be a complete disaster, like especially if you're inputting data. If the original database is here, and then you start inputting data into this database over here, so now you have some data here, and you have some data there, and then somebody else, logs in the system, and then they create a database over here. So be very careful. This is one of those places where working directory can be a very significant thing. Then we're going to create the cursor. So it's interesting, and there's multiple steps here. So the connection is just the connection. It's kind of like just connecting to the database, essentially. What the cursor is, it's almost what it sounds like, it's like the cursor that allows you to send commands to the database, right? So we got the connection, and then we do cursor equals con, so con dot cursor function, and that is going to give us the cursor, right? Then we're going to have down here, we're going to have the SQL statement, the SQL statement, whatever that is, we're going to put that in here, and I'll show you that later. And then we do cursor dot execute that SQL statement. So what cursor dot execute does is basically with the connection, with cursor, it's going to send the SQL statement to the database. But here's the weird thing. When you're updating, when you're deleting, when you're inserting, you then also have to do con.commit. And this is kind of like the programming version of hitting enter. So cursor.execute is basically typing out the SQL on your screen, but then it's just sitting there. If you don't hit enter, it's not going to work. Basically, con.commit is where you hit enter, so it actually executes and commits that command against the database. Be careful. If you do a whole bunch of inserts, but you never commit the inserts, you didn't do an insert. And then finally, con.close, this is where we close the connection. Very important thing, again, with databases, just like with files, if you open a file, you've got to make sure it gets closed, or you'll run into problems. Again, with a database, if you open a database, you've got to make sure you close the database, and so connection.close, that's how you do it. So this is the basic language that you're going to be using, or syntax that you're going to be using for interacting with SQLite with Python. Now, an important SQL statement for your projects is going to be the create table if does not exist, right? So again, as soon as you try to connect to a database, if the database isn't there, it'll create it for you. Well, especially with whatever projects you're doing, you might also want it to create some tables for you so that they're there. So what you have is create table if not exists, table name, and then column 1, the column data type, and then constraints, again, no case or whatever like that, column 2 data type, constraints, so on and so forth. And so basically what will happen is you can run this SQL statement at the beginning of your script. If the table already exists, nothing will happen, no big deal. If the table doesn't exist, it will automatically create the table. And the cool part about this is you can run this for 1, 2, 500 different tables. So you can sit down at the computer, you can run the script, it'll create all the tables that you need, and then you can immediately go to work. You don't have to worry about manually creating the tables in order to make your system do what it's supposed to do. So the create table, if not exists, this is something that should be most of the time in all of your scripts. So here's an example using create table if not exists. So import SQLite 3, we create the connection, SQLite3.connect to example.db, cursor equals the connection.cursor, SQL statement, create table, if not exists, people, name, and age. You will notice there is no semicolon here. When we're writing this in Python and interacting with Python, we do not have to put the semicolon there. Then we're going to do cursor.execute. So basically this is typing it out on the screen programmatically. And then we're going to do commit. We're actually going to hit that enter. Right, and then we are going to close. So if we go over here and we're at my command line, we can see we're at desktop. If I do ls-l, we can see that we only have example.py there. We do not have a database at all. So what I can do is I can simply run this. It's going to run. We're not going to get any results because I don't have it printing anything out. But now if I do ls-l, we can now see that we have example.db. Beyond that, I can do SQLite, example.db, right? Then when I go in here, I can do tables, and I can see that I have a people table that was created. If I do schema, I can see it was create table people with name and age. And so that's how you can automatically create a database and your tables using Python. So now let's talk about parameterized queries. So one of the big concerns, one of the big issues you've got to be thinking about with your database is injection attacks. What happens if a nefarious person or just a bored 14-year-old tries to take your entire system down by trying to do what's called a SQL injection attack? So what a SQL injection attack is basically when you have like an HTML form or some type of input, way to input data into the database. What you can do is you can try to add a semicolon when you're filling out the form and then actually put in like your own SQL string to try to make something happen. And that's what an injection attack is. You escape out of the SQL statement that's supposed to occur and then run your own SQL statement and hopefully chaos will ensue. So if you simply write SQL statements using an F string, so basically you have the dynamic variable values, but you're just simply using an F string to dump those variable values in, it is possible you might have an injection attack occur because the values as they are will get dropped into that SQL string, and so if the injection attack can work, it will. That's where we use parameterized queries. And with parameterized queries, what you do is when you do the SQL statement, so here we do insert into table, column 1, comma, column 2, and then we say values, question mark, comma, question mark. So the SQL statement, where the values are supposed to be, we put in question marks. And so what these are is these are placeholders for values we are going to add when we do the execute, right? So here we do cursor.execute, SQL, so the SQL statement, comma, and then within parentheses, value 1, comma, value 2. So this is where the two values would be. And so again, if these are variable values, that's where it would get put in. And basically what happens in this process is these values get sanitized. So the injection attacks cannot work. So the variable values are then put in to where the question marks is. How this process works is those variable values are sanitized. So even if somebody did try to put an injection attack in, basically the entire SQL statement would fail out and the injection attack would not be able to occur. So that's what we're talking about with the parameterized statements. Now one of the quirks here, just to keep in mind when you're doing this is a tuple. This is a tuple. So value 1, comma, value 2. Where you can run into a little bit of problems is, let's say you just have value 1. So you just want to insert one value or something like that. If you just put the variable name and then close the parentheses, then what's going to happen is SQL or Python is going to see that as a single value, which is not what this works off of, so it will actually fail out. This is supposed to be a tuple. This is a tuple data type, and so tuple data types have multiple values in them. So even if you only use one value, you do value 1, comma, and then you just close the parentheses. And that comma tells Python that this is a tuple that simply only has a value at index 0, so actually process it. Here's an example of being able to insert values into a database table using parameterized queries, right? So we're going to import SQLite 3 as we normally do. And then what I did here for the insert is I created a function to make life a lot easier. And then down here what we have is a while true loop that then calls that function so I can add multiple values so you can kind of see how this works, right? If we take a look at this here, we create the function called add, the name value comes in and the age value comes in. Connection, we're going to connect to the database as I've shown you, and we're going to create that cursor. SQL is going to equal insert into people, name, comma, age, values, question mark, question mark. Then we come down here to cursor, cursor.execute, SQL, comma, and then name, comma, age. So whatever value comes in, that's what's going to replace those question marks. We're then going to commit, so that actually saves it into the database, and then we're going to close. When we come down here, we have this while true loop. It's going to ask me for my name, it's going to ask me for my age, and then it's going to add it to the database table. So if we come over here, right, come to SQLite, and I do select all from people, semicolon here, so I'm in the command line, I'm in the shell, so I have to use semicolon. And when I do that, we get nothing back because there's nobody in the people database. So what's cool here is I'm going to run this, right? So I run this, and it's going to ask me for a name. So as always, we're going to say Bob, we're going to do enter, right? It's going to ask us for an age, we're going to say 12. It's going to ask us for a name, another name, Sue, she's 22. We're going to say Phil is 15. And that kind of gives you the idea, right? So we're doing that while true loop. It's then going through the function to add all these values to the database table. When we come here, again, if we simply run select all from people again, we can now see we have Bob, who's 12, we have Sue, who's 22, and we have Phil, who's 15. And so this is a script here that when you run it, it is going to ask you for values, names, and ages, and then as it loops through, it will send that to this function, and then this is how you're able to insert into a SQLite database table. So now let's talk about doing select statements with Python. So when you do select statements with Python, there's 3 different functions that you can use: fetch all, fetch one, or fetch many. If we take a look at this, so SQL equals select all from people, so that table that we created with people that now has a few people in it. Cursor.execute, the SQL statement, and results. So we have a variable called results equals cursor.fetch all. So what's going to happen here is it's going to run the SQL statement, it's going to fetch all those records, going to bring them back as a list, and then assign that list value to the results variable so that you can do a for loop through it or whatever you want. You will notice that there's no commit here, so when we update or when we are inserting into a table, we have to do a commit function, but that's not here because we're not committing to the table, we're simply pulling values out, and that's why we use something like fetch all. Down here, the exact same thing with fetch one. So fetch one is where it will grab the first value that comes back and assign that to results. Or we can do fetch many, here let's say 20, this will get the first 20 results back as a list and assign that to results. So fetch all, fetch one, or fetch many, I would argue most of the time you're going to be using fetch all, but it's good to know that these others exist. So here's an example in Python of how select works with Python. So import SQLite 3, we create the connection to the example database, we create the cursor. SQL equals select all from people, cursor.execute, that SQL statement, results equal cursor.fetch all. So all those values are going to be coming back to us. We're then going to close the connection to make sure that that's closed. We're then going to print the results. So that all the results are going to get printed basically just as that list so you can see it as a list. Then down here we have a for loop. So for x in results, we're going to print out the individual records. So this is just showing you that it is a list of records, and that's one of the ways that you can step through it. So if we then run this, We can now see, again here, right? So this is where we print the entire results value back. Again, there's square brackets, so this is a list. So Bob, Sue, and Phil, these are the individual records. When we do the for X loop, right? Bob 12, Sue 22, Phil 15. This is when we step through basically that list that came back. And if we want to make it more complicated, we could pull out these individual values by their index, right? So X0 would be Bob, X1 would be 12. X0 would be Sue, X1 would be 22, so on and so forth. So that's the basic idea how you do select statements with Python and SQLite. So when you're doing select statements, obviously you can use filters. So again, using conditionals for trying to find the specific information or specific records that you care about. So select all from table where column is greater than question mark, right? So we're using that parameterized query here. Cursor.execute, SQL, comma, and then value. And you see that there's that comma there because this needs to be a tuple. If you don't put the comma there, it will fail out. So here's an example of Python using a filter. So import SQLite. We're going to do a find. So we're going to be looking for any people that are above a certain age. So age is going to come in. We create the connection. We create the cursor, SQL, select all from people where age is greater than question mark. Right? Cursor.execute, SQL, comma, age, comma, right? Make sure you have that comma there. And the results equal cursor.fetchAll. Then we're going to close, and since this is a function, we are then going to return the results. We come down here to our little while true loop. So we're going to do age. So we're going to create a variable called age equals input. What is the minimum age that you're looking for? Results equal find age. So basically, it's going to be that minimum age, and we're going to get the results for anything above that minimum age, and then we're going to simply print that out on the screen. So if we go and we run this, I did add a few more records, just so you get a little bit more up on the screen here. So if I put a minimum age of, let's say, 10 in, and we hit enter, we see Bob is 12, Sue is 22, Phil is 15, Tim is 20, Frank is 13, other Phil is 77, and Tom is 50, right? It's asking me for the minimum age again. And so what if I say 49? Then we see Phil is 77 and Tom is 50. What if I say, I don't know, 20? Right? Then we see Sue is 22, and Phil is 77, and Tom is 50. You'll notice I did greater than, not greater than or equal to. So even though we have Tim, who's 20, that doesn't show up here. But that basically just gives you an idea that yes, you can continue to use the filters even when you're using Python, and you're using the parameterized queries basically the same way. So now that you've done insert statements and select statements and parameterized queries and the whole 9 yards, doing an update statement should be pretty simple, right? Update people, so the table set name equals question mark, where row ID equals question mark, right? So an update, just like we've done in the past, execute SQL with name and ID. So I want to go over to VS Code now and show you how this particular little example works so you can start to get an idea of how you can start building slightly more complicated projects using Python and SQLite. So what this example is going to do is it's going to print out all the records for people in our database. It's going to give us the row ID. We are then going to be able to pick a row ID, and then we're going to be able to change the name of the person in that row ID. I just want to show you how this works, and then we'll go and take a look at the code. So we run the code now, and basically we print out all the records. So it's just like this to make it easier to look at. So 2 is Sue and 22, 3 is Phil at 15, 5 is Frank. We got Timmy here at 20, and so on and so forth. So let's say I want to change Bob's name. He doesn't want to be Bob anymore. He wants to be Bobby, like a real adult, right? So basically we're looking at the row ID. So row ID is 1. So I plug that in, and then asks me for the new name. What do I want the new name to be? So I want it to be Bobby, because that's a little bit more mature. And then I hit enter, and now we can see the row ID of 1 is now Bobby. Sue might be looking at this going, hey, why am I lowercase? I want to be uppercase, so I can plug in 2. Then I'll do Sue for uppercase. And now we can see that we changed that value here. So this is what this example is going to do. This is how we're going to be updating records using Python. So here's the Python script. You'll notice there's actually two functions here. So basically I want to go down to the while true loop, explain this, and then we'll go through these two functions, right? So import SQLite 3, we're going to have a find function, and we're going to have an update function, right? While true, results equals the find function. So what this is going to do is we're going to go here, and this is where we're going to connect, and basically we're going to select the row ID, the name, and the age from people, right? Again, we need an identifier to be able to identify a record to make sure especially that we don't modify multiple records at the same time. Row ID for this particular project will work fine. We don't have to actually use a primary key for this. We just need that unique identifier. So this is where we're going to print out the row ID, the name, and the age. We're going to execute, we're going to fetch all, and then we're going to return the results, right? Those results, right, results are going to get returned here, and then we're simply going to print out those results on the screen so you see all the records that come back, and the important thing is the row ID and the name because that's what we're going to be modifying. We're going to use the input function here, so ID equals input, ID to change, name equals input, the new name. Right? And then we're going to do here, we're going to update the ID and the name. So we're going to go to the update function, it will update, and then it'll loop, and we'll do the find, and it will print out all the results here. Right? So we go up here to the update function, again, very simple, the ID and the name. So we get the connection, we get the cursor, update people, set name equals question mark, where row ID equals question mark, right? So the ID and the name, execute SQL name and ID. So this is an important thing to be thinking about with this, is realize when we bring it in, it's ID name here, but set name equals question mark. So we have to put name first, and then row ID equals question mark, we put ID second. So when we're using these question marks, they're basically indexes. Think of this as 0 and 1. So name is going to be at 0, and ID is going to be at 1. Name is at 0, ID is at 1. Right? Then we're going to commit. We're going to commit because this is an update, and we're going to close, and then basically that is just simply going to loop through, and we're going to continuously be asked to update records. And so this is an example. It gets a little bit more complicated on how all of this works. And then finally, you can delete a record using Python, and I'm just going to show you here, because again, you got to be careful with deleting records. That can go badly, right? We're going to connect to the database. We're going to create a cursor, delete from table where row ID equals question mark, execute SQL, and then ID comma, make sure you have that comma. We're going to commit, and we're going to close. And so again, if you followed along up until this point, that's all that's required to do a delete. Again, be careful with deletes. I would argue you should have an additional row in your table for either active or inactive, or active and deleted. I would argue it's probably smarter to update a record to a deleted status than it will be to actually delete the record, but you do you. So that's the basic idea of using SQLite and Python. Again, all of this here is relatively simple. We are just adding, again, importing the SQLite module here. We're connecting to the database. We're creating that cursor. We're executing, and then we're committing. So there's a few steps here that you're just going to have to follow, but this is like everything in programming. Once you figure this out, you'll get very used to it very quickly. Now, if you do not know Python, right? So if you know Python, everything I showed you should be either relatively easy to understand, or you can go back and read this a couple times and you should be able to figure it out. If you do not know Python, we do have a full Python Introduction to Python series here at Silicon Dojo. I would recommend you go take that, and if you take that, then you'll start to understand this thing about functions and modules and all of that kind of stuff. But this is a basic overview of how you can use Python to interact with SQLite, and again, this is going to be be an invaluable tool for us going forward, because now we have a place where we can store records. So we can make API calls with Python and then store the results into our own local database. We can use the Bottle Web App Framework to ask for information from our users and then store those records into a database. We can get sensor values from 1, 10, 10,000 different sensors, and we can now dump that information into our database so that we can process that and actually try to bring some value out of that information. So adding SQLite to Python is an absolutely awesome thing. Again, once you start understanding the structured query language, then simply bringing it into your Python script is relatively easy.